Hello everyone, this is Deepak Joshi, and today we are going to talk about a very interesting concept that is CRAG, Corrective Retrieved Augmented Generation. Before understanding Corrective RAG, uh, I am guessing that we all know what is RAG. RAG is a process by which we give context to an LLM. An LLM becomes context aware about the documents the user has provided, or the organization has those documents in their knowledge base already. Um, let's look at RAG. Like this is how like the diagram for RAG looks like, or the architecture. It's pretty simple. A user makes a query. Um, then it goes to a retriever like a vector DB, which is in the most cases is a vector DB which stores embeddings of the documents that has been uploaded. Like it looks into the documents, search relevant files or chunks, and then those relevant chunks are being shared to the LLM, and then LLM judges the relevant context and the initial query and gives us the response. uh, like there is this thing, there is a document, right, that is being uploaded as an input by the user. This document gets chunked. Like what is chunking? Chunking is dividing a whole document into some subsets. Let's say we have a document containing 100 pages, which and every page contains around 2000 characters, or like uh, 200 words, or more than that, I would say, like 1000 words, let's say, and 10,000 characters. Now we would love to get information from this document, but it should be stored in a manner such that it should be searchable. Like I don't want that I go in a for loop from starting of the PDF to the end and then find the relevant words which were there in the user query, right? So what we do is we divide this uh, input into chunks. Let's say we divide it into 1000 character chunk. What does that mean? Like we'll take this input file, for every 1000 character we'll split it. Like we'll have multiple small files from it, like this, and n number of things, right? So this is chunking. But right, and now we can store them into a vector DB by creating an embedding. To create an embedding is not we can assume, we can think of embeddings as vectors. Like if we remember x I cap, y j cap, and z k cap that we studied back in school days or in college. uh, Now this vectors can be stored into a vector database, and then can be retrieved based on the retrieval algorithm that we would love to follow. But one of the use case that might occur over here is, let's say had a sentence. My name is Deepak Joshi, and I'm this many years old, and I work at this company. I love to do this, and I enjoy doing that, and I love to do that in future, and I would love to visit this place, right? And I'm guessing it is more than 100 characters, let's say, and our chunk size was 100 characters. Now this whole paragraph will not come into a one chunk, right? So we'll have to go and create two chunks, but this was a single paragraph that I just said. So now my if I retrieve only one chunk, then it will be like not proper. The LLM might let's say it got cut into I would love to visit this, and then full stop. That place in new the future is into a newer chunk. So what we do is we have overlapping in the RAG. Like I'm explaining a little bit about RAG, and then we'll go into CRAG and why do we even need CRAG, right? So here we do chunking, let's say of 100 characters, but we make sure that we overlap something, so that in the next one there's something called overlapping that we do for the chunks, which is like generally, like I've seen 10% is the amount, but people prefer to do it the way they find their models or their agents to be outputting bit responses, I would say. So how does this works is, let's say there is a paragraph that is 100 words. So what it will do is it will only have 800 for this paragraph, have 100 for the previous one, and have 100 for from the next one, so that this becomes overlap. Now the next one will have the same 100 chunk over here, the next 800, and the next 100. I think it has become 20% in my example, but like we understood, right? It will be 50 and 50, 50 and 50, 50 and 50 for 10%. This is overlapping, and once this is being created, then what we do is we take all this and make an LLM call to embedding model. We create embedding out of it. Embeddings are nothing but vectors, right? And these embeddings, which are like shared to the LLM in batches, so that we can reduce latency, and there are parallel calls that happens to the LLM to create the embeddings. Once these embeddings are created, we store them into a vector database, right? VD, not VC. VCs are venture capitalist, VD is vector databases, right? Now, when we have everything in our vector databases, then this thing comes into the picture. Like this is our vector database, like this point, and then user makes a query. Like this query will have stuff such as related to the document, maybe related to the document or not related to the document. We'll see what happens. I'm assuming right now that it will be related to the document. So it goes to the retrieval. It looks into the vector database, gets the relevant chunks, and then we share those chunks to the LLM, and then LLM has the main user query and the chunks. Then it generates a response, right? But where does the issue comes? So recently I was working on a project where we had a agent. Let's just name it general agent, right? Now this general agent has its own knowledge base. What is a knowledge base? For now, let's just think of a vector DB that the organization has provided. Like these are the set of policies that our organization follows, and our agent should be aware of these policies, right? So this agent has access to the knowledge base. Uh, but what happened? A user comes in and asks a thing that is not into the knowledge base, or like asks a thing that is not relevant to the knowledge base. Let's say this knowledge base is about company policies, right? Uh, and it has 10, 20, 30 documentation. Uh, and a user comes in and asks about leaves sandwich. Uh, it's an example that I'm taking. I was reading on Reddit that some companies uh, has this. I don't know what do we call those companies as, but the some companies has this. If you take a leave on Friday and then on Monday, then it becomes a sandwich, and one of your weekend will be considered as a off day as well. So and a person or a person working at a company asks this agent, does this company follows leave sandwiches or something like that? But this knowledge base doesn't have any word containing sandwiches. It has words related to leaves. So what this general agent will do is it will go into knowledge base and pick the relevant chunks that will have the word leaves, and it will show the user the leave policies. Like you can take up to max 20 days of leaves, you have your weekends off, and la la la, but nothing about the concern, that initial concern that the user had, right? Because the context was polluted, like not polluted but correct, I would say, because um, it retrieved the chunks that had word leaves, but sandwiches was not there, right? uh, like a very general or a very specific example I'm giving, it can be replicated to a lot of scenarios. It happens a lot of time when we try to productionize agents with knowledge bases, or with user giving documents as the context. So how do we deal with these such scenarios? Uh, if we all agree that the this is the scenario that happens, that can happen or that happens in a production grade AI agent, then in that case, the thing that we are discussing right now, CRAG comes into the picture, right? Uh, what is a CRAG basically? So here we saw that we have a retrieval, a vector DB, right? So I'll just draw things over here. So we had the input query, I would say, that goes to the vector DB, and then that gives us chunks, right? Like that can be passed to the LLM, and then LLM gives a output, or I would say response. Okay, I think I'm cutting myself. I'm cutting the text here. Now this is idle. This is the idle case. But where CRAC comes into the picture is when we have chunks, we have a validator, or like a, or what do we call? I am forgetting the name. We have retrieval evaluator. Yeah, I'll just share what I saw on the screen. Okay, I think I made a. I don't know where that went now. Okay, I think I lost everything. Let's see. So we had input. We shared it with Victor DB, like the query that gave us some chunks, right? Then we passed it to an LLM, and that LLM gave us the output. That is clear. But now this was the traditional RAG that we follow. In CRAG, what we do is we introduce a new thing, that is retrieval evaluator. What is a retrieval evaluator? It evaluates whether the chunks that has been retrieved from the vector database based on the user query are up to the mark or not. There are different ways of doing it. Like either this retrieval evaluator can just directly say yes or no, or can provide a confidence score to every chunk. Like uh, let's talk about this retrieval evaluator use cases. There can be three cases for this retrieval evaluator. Like this retrieval evaluator, I'll just do a little zoom out. So we have chunks, right? And then we have an LLM that does all this. An LLM that works on the retrieved content. But now we have in between a retrieval evaluator. What does this retrieval evaluator do is it looks at the chunk. So looks at the chunk plus the input, like the user query. So these are both the things that that the retrieval evaluator looks at it. So it looks okay, so this is the chunk that we have got from the vector database, and this was the initial user query. Now there can be three cases that can happen from here. Like the first case is the retrieval evaluator says, "Oh, so the retrieved context from the vector database looks absolutely great based on the user query. The user query was uh, like was in very aligned with the retrieved content, or the retrieved content is very aligned with the user query. So it will say all good." So in that case, if everything is good, the chunks will go to an LLM plus the user query, and everything happens. Then there is another case, not good, right? The user input query was about Batman, but the retrieved chunks are about a man playing bat ball. So which is which are not the right things, right? So it will say not good. So in that case, there are fallbacks that a lot of company there are a lot of ways to do these fallbacks. Either the LLM will use, now in the next step, this LLM either will use its own parameterized data, like what is a Batman, an LLM knows, or we can provide it a external tool such as web search to look into that, right? So these are two pretty standard use cases, but now there are other cases as well which are like in between, not sure, right? The policy leave example, the LLM, the vector database retrieved sick leave policies or the policies for the company, which are right, but the user asked for a sandwich leave, which was not there. So this retrieval evaluator will uh, will be like not a little bit confident, not that much confident to make it to all good, or not that much uh, like confident to make it to not good. So it will be in between. Like this is the scenario where we will be utilizing an LLM to summarize the context or to look into the context, and an external tool, web search, and then we will combine both of them to make another LLM call. A lot of LLM calls happening over here. I know your concern, like for an production ready environment, we would love to reduce latency, but that will come when we'll talk about the latency part. There are a lot of ways to reduce latency as well. So if we are clear over till here, I think I tried explaining what I am thinking right now. Let's just look from where we started. We started with an input. That input query goes into a vector DB, retrieve some chunks. Initially, that those chunks used to go into an LLM, and then that LLM used to generate outputs. But now there are ways of doing. There is another way. Like we are introducing CRAG, that is retrieval evaluator. What the CRAG does is it looks at the chunk and the input and then judges them into three criteria, that is all good, in between, and not good. So if a thing is all good, like the context is pretty much aligned with the user input, then in that case it just passes that context along with the query to the LLM. And in the second case, if it is not good, like the retrieve context is not even close to what user has asked, then in that case it will use the LLM's parameterized knowledge, or it will use an external tool, for example web search, or if we have anything such as look into a DB, or any endpoint, right? Then there is a scenario where things will be in between. Like it is not confident, like it is not confident whether the chunks are relevant to the user query or not. In that case, it will do a combined approach, use LLM to summarize the chunks or to process it, and then may use an external agent as well. So these are the things. uh, in theory, let me share what uh, yeah, let me share what we can. I am looking at this particular paper. Yeah. So this is a paper that was published in 2024, 7th October 24, Corrective Retrieval-Augmented Generation, which is very similar to. So here we can see what is Henry's Field's occupation. The answer is accurate. What was the screenwriter for Death of a Batman? Then in that case, Batman of the murder of Bruce Wayne's parents, went like, which is like inaccurate, right? Both are coming from the documents, like from the retrieval and an LLM call. So what they proposed is CRAG. So, the most important thing in this is we should read the paper, like if we want to, but I'm providing a crux over here. The important thing in this paper is this diagram. Like here we can see, let me just, yeah, zoom in a little bit. So here we can see we have X, that is if retrieval documents are correct to X, then X is the input, who was screenwriter of Death of Batman, the initial thing we saw. We have a retrieval evaluator. It goes to the retrieve chunks, which are D1 and D2, goes to a retrieval evaluator. Now there are three cases that can happen to this retrieval evaluator: correct, ambiguous, incorrect, right? So if the retrieved documents are correct, in that case it will go into knowledge refinement. This knowledge refinement, it's pretty interesting, I would say. Knowledge refinement, what this knowledge refinement does is, you remember I talked about a paragraph like, I am Deepak Joshi and I'm this many years old and la la la. So there are a lot of sentences in that paragraph. There are different ways of doing knowledge refinement. One of the way that I can uh, uh, remember right now is like splitting the whole chunk into paragraph into sentences, and then asking a fine-tuned model whether this sentence belongs to the user query or not, which will be like faster if a model is properly fine-tuned for that. Here they talked about, I think, a model that is gamma or something. You can look into this. I think I read it. I don't remember, to be honest, so I'll not talk about that. And then what it does is it's like it divides those chunks into step 1, step 2, step 3. It filters those based on an LLM, and then it combines a k internal knowledge internal, like it combines the whole sentences which are relevant to the user query, and then it becomes the knowledge internal. Then there is a case when the retrieved document is incorrect. So in that case, what it does is it looks into knowledge searching. It can be a web search tool, right? So it looks into a web search tool, tries to get information from the web, and then creates a knowledge external. And then at the end, uh, like if it's pretty simple. If like the retrieve document is correct, then it will just do user query plus knowledge internal and send it to the generator, which is an LLM that will generate the output. If it is incorrect, then what will happen is it will share the user query and the knowledge out external to the LLM, and the LLM will generate the responses. If it is in an ambiguous situation, like it is not sure, then in that case it will do both of the things, like knowledge refinement and knowledge searching, like knowledge internal and knowledge external. And yeah, what it will do in that case is it will share the user query, the knowledge internal and knowledge external, to the generator to generate a response. So, and then in that case, we will cover all of the cases. And if we'll ask what is Batman, then in that case it will not share a person playing cricket. It will actually share what is Batman and where that character come from. I hope all of this made sense. It's easier to implement this. I think it's important to know that this is also a way uh, when using which we can implement RAG, because then uh, it will help us to build systems that are pretty good and pretty reliable as well, and are not outputting vague responses based on user queries. Let me know if you would love to chat about other system architecture things related to AI or anything in general. I'm happy to talk about anything. So yeah, feel free to comment if you have any doubts. See you in any another video. Bye bye. Take care.